Good afternoon, and thank you for joining us on our call today. My name is Christina Spearman from Transcat, and I'll be your moderator this afternoon. Our webinar topic is Principles of Low Resistance Testing and Applications of the DLR2 Low Resistance Ohm Meter. This topic is being presented by Brian Hammerschmidt from Megger. Brian has worked with Megger for 23 years, 7 years as a manager of the Worldwide Authorized Service Center and Local Service Department out of Valley Forge, Pennsylvania. The last 4 years, he has worked as an applications engineer supporting U.S. distribution. We expect today's presentation to last roughly 45 minutes, and then we'll answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Brian.
Okay, thanks, Christina. Thanks, everybody, for joining us on this webinar today. As Christina mentioned, we're going to be looking at some principles of low resistance testing today, and then look at some applications for the DLR2 low resistance ohm meter. So just a quick outline of what we'll be looking at today. Look at what do our end users want, what is considered a low resistance test, when and why we should measure low resistance. Then we'll look at some of the benefits of low resistance testing. Then we'll look at some example applications, and then finally we'll look at the DLR2 itself, some of its features and key characteristics, and then we'll end with questions. So what do our end users really want? Do they want a DLRO, a digital low resistance ohm meter? What we found in talking to our customers, they really want peace of mind, they want reliability, they want cost savings, and they want prevention rather than a cure. So we know that it's a lot less expensive to find a problem and correct it before a total failure occurs. So what is a low resistance test? Well, ductor testing, or low resistance testing, also known as contact resistance test, just measures the resistance of electrical connections. Of course, these can be between any two conductors, so there's a wide variety of cable connections, bus bar connections, etc. Just a note here on the name ductor. This actually comes from the original ductor low resistance ohm meter that was developed by Evershed and Vignol back in 1908, and that is one of the companies that evolved into Megger. So the term ductor really just comes from the word conductor. So basically it's just short for a conductor test. These next few slides we'll take a look at just explaining what is considered to be a low resistance test. So on this chart you'll see at the high end of resistance are your insulation testers. So you may be familiar with these. Megger makes the MIT insulation resistance testers. And these use a high voltage and very low current, which allows them to read very high resistances. And again, they're looking for the integrity of insulation. And these go up to 20 teraohms, even actually 30 teraohms. That's 30 trillion ohms. So the opposite end of what we're looking at with low resistance. So then you have your general resistance testers. These have a range of around 10 ohms up to 1,000 kilo ohms. You'll see there they use a low current, low voltage. Then we have our continuity testers, and these range again 0.01 ohms up to about 100 ohms. And these use 200 milliamps as a test current. Then we get into the 4-wire measurement. This is low resistance testers. When you look at the range there, it's 0.1 microohms all the way up to 2,000 ohms. And these are using a higher current, you'll notice there, from 1 amp all the way up to 600 amps for some applications. So in general, low resistance tests are generally considered to be below 1 ohm. And again, they use a higher current and a low voltage in order to read very low resistances, all the way down to 1/10 of a microohm. And this is a 4-wire test. The reason for this is it removes the effects of contact resistance and the test leads. So a 4-wire Kelvin measurement makes it possible to accurately measure resistance values that are less than 0.1 ohms by eliminating the inherent resistance of the lead wires that connect the measurement instrument to the component being tested. So again, these are reading things much lower than a continuity tester. So when do we measure low resistance? How is this testing used? Well, there's a go, no-go test. This is just checking for correct resistance when they install or commission equipment. And it can also set a baseline for future measurement comparison. They're going to look for an increase in those resistance readings after they install or commission equipment. Then there's commission monitoring. And again, just looking for an increase in the readings that can indicate a problem. And then there's like testings. For example, resistance readings on similar joints on bus bar. They should be very close to each other, those readings. So identifying unacceptable increases in resistance. We want to prevent equipment damage, certainly. We want to increase efficiency. We're looking for a low resistance path for any fault current. And you probably know that a fault current's always going to take the path of lowest resistance. We're looking for static electricity dissipation paths. And then also to drive predictive maintenance, we want to spot any increase in resistance and correct it before it becomes a major problem. We have a pretty dramatic sequence of photos there. I'm not sure if you can see it. It's a little blurry, but this is an airplane that lightning strike comes down, and you can see it's actually going around the aircraft and down to the ground. And we'll talk a little later about applications for the aerospace industry, why this is important. So now we're going to look at some of the things that can cause an increase in resistance. So in manufacturing or installation, or even after a repair, maybe the bolts aren't tightened enough, or maybe they're over tightened. We'll take a look at that a little closer in a few minutes. If you got poor or dirty or rough mating surfaces, these can certainly cause an increase. And then damage like frayed wires or broken strands, these will definitely cause an increase in resistance. And then following a long period of shutdown, you have equipment that's been sitting out in the elements for many months or longer. And you can certainly see corrosion from dampness, moisture, and even chemical attack. Excuse me. In service, so there's environmental and chemical attacks. Even the air will oxidize some connections. Certainly moisture getting in, oil and salt will degrade it even more quickly. And there's chemical corrosion. And then there's electrical stresses. There's over voltages or impulses, which are fairly common. These can cause problems with connections. Excuse me. Mechanical stress. We have vibration, impact, stop and start, certainly with motors and a lot of mechanical equipment. There's metal fatigue, and then just equipment that heats up and cools down. And then there's even poor solder joints on PC boards. So we'll look at just 5 benefits of low resistance testing. Again, we're looking for unacceptable increases in resistance. We want to make sure we have a low resistance path for fault current or lightning strike current. And we just need to make sure there's dissipation paths for static electricity. So all these things protect people, they save energy, and certainly prevent fires, and then just protection of equipment, buildings, wind turbines, etc. And then also in production environments, you want to ensure quality. So we'll move on now to some sample example applications. Here's an example of testing on a bus bar. So you'll note that there's one connection to the bus bar itself. This will be the same for all 4 of these tests. And then they start to check each point of connection. So here they're checking the other side of the bus bar. Here they're actually checking the bolt from the bus bar to the bolt. Here they're checking from the bus bar to the crimp that's on the wire. Then here they move down to the wire just below the crimp. You'll notice in this example, this increase up to 1.8 milliohms. Again, just to point out, a digital multimeter or continuity tester, if you hook one of them up to this, you may read some resistance, probably it's going to read 0, and you would not know that there's a problem here, this 1.8 milliohms. So Megger's done a lot of testing comparing multimeters and continuity testers to a DLRO. And again, the multimeter may provide a resistance reading, but it's not going to detect an increase, as in this example. So detecting this increase, why is this important? This allows the customer to address the issue. In this example, it's a poor crimp. And they can detect it before it becomes a serious issue. They can correct it. And in this case, something like this would create quite a bit of overheating. And that's eventually going to lead to complete failure of that joint. So we can use DLRO testing also to check torque. Here we have a graphic of a correctly torqued electrical connection. We have full surface area contact. And down here, we're looking at one that's been over tightened. And this is actually a really common issue. You know, the technician, the mechanic comes in and he thinks he's doing a good thing by tightening the connection as much as possible. But this can actually cause a distortion, and that reduces the contact area, as you see here. And that's going to increase the resistance, of course, and that's going to lead to overheating and eventually a complete failure of that connection. So here's just some typical faults that could be prevented. Here's some thermal images here. You see a hot spot here on that joint connection, here on a terminal block. And over here, of course, you can see this is overheated so much that the bolt has actually turned red hot. And this connection clearly is in danger of failing if it hasn't already. Here we just have examples. There's a high resistance fault in a motor. Here we have some poor crimps on high voltage wires. Down here we see a poor connection on a terminal block that's resulted in, you know, the terminal block has just melted away. So some example applications, I'm not going to read every one of these, but this is really just to point out to everyone that there's a really wide variety of applications that exist for low resistance testing. So certainly in the electrical manufacturing processes, testing switches, we're looking at cable resistance, motors and generators, fuses, cable looms, UPSs, certainly car batteries. We're looking at plate weld resistance. And then even in electronics, just looking for track resistance of PC boards and component testing. Industrial manufacturing plant maintenance, certainly many applications there. Looking at power systems, again, with motors and generators. And then even at universities and colleges, there's a number of research applications. And of course, these are being used in the mining industry for checking pumps and lighting and underground supplies, et cetera. We mentioned this a little earlier, the aircraft assembly and maintenance. The aerospace industry is very, very big on this. There's a number of things they need to check on an aircraft. You know, they need to ensure a stable ground plan to protect that aircraft from static electricity and lightning strikes. We have aluminum refineries, shipbuilding, raw material processing, the automotive industry, power generation and distribution, certainly bus bars that we talked about earlier, lap joint test, cable joints, fuses, UPS systems, looking at battery straps, so the quality of the connections there, and carrier to plate weld resistance, very important. And then even military vehicles, trucks, tanks, etc. Usually checking for ground bonding to the vehicle chassis, for example. Certainly we see this in buildings. You've got wiring, lightning protection bonds. And then wind turbines. This is one of the major applications for the DLRO2 that we'll talk about a little later. During manufacturing and installation, these things have lightning protection on them, from the wingtip to the base, or even component parts in manufacturing. And we do have long test leads available for this application, which we'll talk about shortly. But very important, these wind turbines are extremely expensive, and there's lots of dramatic video out there. You can look on YouTube and see a lightning strike. This is one of the top things that is a problem for wind turbines, and it just absolutely destroys them. So very important to test for their lightning protection. Here's just a general list of industries Again, I won't read all of these, but again, just to let you know that there's a really wide variety of industries that test for low resistance. So we like to say the lowdown of low resistance testing, better than insurance. You know, insurance will come along and pick up the pieces after something goes wrong, but in low resistance testing, we're really looking to prevent something from going wrong. We want to prevent it, correct it before it becomes a major problem. So now we'll get into just looking at the dealer 02, at this model. Again, the Ductor low resistance ohm meter. It's got 2 amp output. Can read up to 2,000 ohms with 1 micro ohm resolution. It's handheld, of course, easy to use. And maybe most important here is it provides reliable, repeatable measurements. These first 4 bullets here are based on key customer requirements, based on our research that we've done. Just a note on the 2,000 ohms, someone might ask, well, why would you need to read something that high? We're talking about very low resistances. The answer to that is that it's useful in production environments for testing component values, and it can also show the difference between a really poor connection and a complete open circuit or incorrect connection. Then these last 3 points are just key characteristics of the dealer 02. It's got a rugged molded case, rechargeable batteries, and a color display. So where's the dealer 02 fit with our current offering of models? You'll see here on the right-hand side a number of our digital low resistance ohm meter models. And obviously the dealer 02 is the only one that's handheld. And I should mention here that most of these models provide 10 amps of current rather than 2. So just to touch on that, some differences there. Testing at 10 amps, this higher current can provide a better ability to heat and expose weaknesses. The dealer 02 is about 4 watts of maximum power output. Dealer 010 HD has 25 watts. And this can become important if you're testing, for example, large high voltage circuit breakers. You may need a higher test current to break through contamination that could exist on the contacts of a high voltage circuit breaker, just for example. The 10 amp, again, provides an element of diagnosis. It has the ability to find issues such as contamination or current carrying weaknesses. And of course, because these units are much larger, we can put a bigger battery in them, and therefore you'll have some improved battery life. But the dealer 02 really, it just effectively fills a gap in the low current dealer 0 range. Some advantages of this when testing at 2 amps, also has the ability to test at 1 amp, of course, but 1 amp or 2 amp 4-wire measurement, it's still going to find issues that are not possible to find with a continuity tester, digital multimeter at 200 milliamps. It's got high enough current to provide 1 micro ohm measurement resolution. Then obviously it's lighter, smaller, it's easy to carry and store, less weight improves the safety. And then you have the convenience, it's less battery capacity is required, so we can just use AA batteries, very simple. It's just, and it's a more cost-effective solution. So again, just truly handheld, high performance, again, simple to use. We currently have the dealer 010, for example. That model enables a user to hang it around his neck, that earlier photo of the guy up on the top of the wind turbine. And this offers, of course, hands-free operation. These are hands-free to make connections, etc. It's in a transport case style, but again, it is not a handheld. So this is where the dealer 0 fills the gap here and provides a handheld option. So just some of the main points. This unit has 3 main test modes. It's got normal resistance test. It has a long lead test mode, and then an inductive resistance test mode. And we'll talk about these features in the coming slides. The normal test mode is for general low resistance testing. The long test lead mode, this is for any applications that require long test leads. It can be over 400 feet. Perfect example of that is the wind turbines. And then inductive resistance mode, and this is for example for testing motors and generators. 5 different current options, and then unidirection or bidirectional. And I'll just note on that in low resistance tests, there are thermal EMFs, that's electromotive forces, and these can produce voltage gradients across the test sample. And although it's only in the millivolt level, these can still cause fluctuations of several digits. And this instability really defeats the purpose of a high precision measurement. In addition, there's AC interference that can be induced by nearby electric or magnetic fields, electrical imbalance, and so on. So this problem is overcome by taking readings in forward and reverse polarity, and then it provides the average. So that's the purpose of a bidirectional. And the unidirectional mode, this applies a current in one direction only. And while this type of measurement doesn't negate standing EMFs, it actually speeds up the measuring process. So if you have, for example, an application such as battery strap test, it's not necessary to do a reversed current test on those. And so you can save some time by using the unidirectional option. And then there's test options here, the test button start or auto continuity start, single or continuous tests, and then inductive manual stop or auto stop. And then there's a display option for forward and reverse results, or it can actually show you the previous 2 results. We'll get a little more detail on these in coming slides. So just some key features, very easy to operate. There's no hidden functions. Everything's right there on the front on the selector switch and on your screen. There is a Cat 3 600 volt or Cat 4 300 volt safety. Again, we'll go into these features in a little more detail shortly, but I'll mention here that the Cat rating defines the level of transient voltage or voltage spike or surge that the instrument has been designed to withstand. The unit's got high noise immunity, active protection and fuse protection. Again, we mentioned the inductive mode and long test lead mode, and it's got a difference meter. We'll talk about that shortly. And then this is a nice feature. If there are any firmware updates to the unit, these can be updated in the field by the end user by using a USB stick. So we'll take a look now at the long test lead mode. Again, just a separate, easy to select mode, optimizes the unit to be used with very long test leads. You might ask, why do you need to be able to test with 490 feet of test cable? Here's why. This is one of the main applications for this. Testing lightning protection on wind turbines. The average height of a wind turbine is about 300 feet. So they're quite tall and obviously require a long test lead to be able to conduct that kind of testing. You can test aircraft bonding and resistance between lightning receptors. Again, they may be 100 feet apart from each other, so important to have the long test leads for that. And then there's subsea cable laying. They test safety ground connections there. So the DRO2, there's cable reels. They're offered. They're lower cost and a lighter weight. And that lightweight equates to safety. It's just much safer to use, especially if you're this guy up on top of a wind turbine. The difference meter. So this is a plus and minus percentage scale that shows at the top of the display. So the first measurement you would take becomes a 0% reference, and then each measurement you take after that will cause a pointer to move, and that'll indicate the percent of difference from that reference. Just to note here, we just know from speaking to aerospace engineers and other engineers that repeatability in the readings is really crucial. There's a lot of low resistance meters on the market that don't provide repeatable and stable readings. So the DLR02 has been proven to provide really stable, very repeatable results. So again, perfect for aerospace and other applications. And the difference meter just provides a quick and simple way to compare readings. And you can clearly see the repeatability of the readings. There's a few more applications for the distance meter here. If you're testing a lot of similar connections, we talked earlier about bus bar joints. Very easy to identify connections that have a slightly higher measurement. And again, these small increases in resistance can be an indication that there's a problem and it'd be a future failure. And just important to reiterate that these small differences in resistance cannot be detected using a 200 milliamp continuity tester. We have the auto stop function on inductive when you're in the inductive test mode. So inductive loads such as motors, generators, they can take a longer time to fully charge, so the readings can take longer to stabilize. So what the DLR02 will do, you're in the inductive mode, it'll automatically stop the test and hold that final value as soon as the measurement has become stable. So you don't have to stand there and watch it and wait for this thing to stabilize. It'll automatically do that for you. Some applications for that, it's great for testing small to medium-sized motors or transformers in a production environment. Again, you can start the test, not have to watch for the resistance to stabilize as the inductance becomes charged. One other feature here, the DLR02 can display 3 test results at the same time. So this is perfect for applications where you have 3-phase, as for example, stator windings on a motor. You can look at all 3 of those phases on the screen at one time. So this just talks about the protection, 600 volt live voltage. This unit knows if there's live voltage there, and it happens. Even the most experienced guys may inadvertently connect to a live line. So the DLR02 is going to sense that. It's going to inhibit the testing, and most of all, it's protected from damage. Again, just ideal for working in industrial locations. You prevent wasted time with having to replace blown fuses or even having to return the unit if it gets damaged. You send it in for repairs and nobody wants to do that. Again, some features here. Standard AA rechargeable nickel metal hydride batteries, and they can even be changed to alkaline. So guy brings it back to the shop, forgets to charge it up before the next job. You get out in the field, oh no, thing's not charged. No problem, you can put alkaline batteries in there. And the unit does have a sensor, and it'll know if somebody puts alkaline batteries in this thing and then tries to charge it, it will not allow that to happen. So again, just protection for the unit. So IP54 rated. This IP code stands for Ingress Protection Code, and sometimes referred to International Protection Code. So what that number 5 indicates is ingress of dust is not entirely prevented, but it must not enter in sufficient quantity to interfere with the operation of the equipment. And then that second number 4 is for water splashing against the enclosure from any direction shall have no harmful effect. So what this means is the DLR02 can be used out in the rain, can be used in a dirty environment and continue to function with no problem. So it's just important to note, if you see a competitor out there, we know some competitors have claiming an IP40 rating. That first digit 4 means it's got protection against objects that are greater than a millimeter. So, some wires, screws, etc. But that second digit is important. That 0 means there's no protection at all from water. So we have a picture of a competitor's unit here, and I can tell you right now that thing cannot be used out in the rain. So that is a distinct and important disadvantage, and a great advantage for the DLR02. Display settings. So it has a yellow display background that can be changed to white in the settings. And this is really great for reading when you're out in direct sunlight. There's a lot of instruments out there that are difficult to see the display. And this unit, not a problem at all. Very bright display and very easy to read. And then the difference meter, if you're not using that, if you don't need to use that feature, you can turn it off, and then the main display digits are even larger and easier to read. So just in summary, DLR02 provides high performance in a handheld instrument. And time for questions.
All right, thanks, Brian. That concludes our presentation portion of the webinar. We'll now move into the question and answer session. I wanted to mention that we also have Jeff Jowett, the Senior Application Engineer from Megger, on the line as well, who can field any questions that you may have as well. Just as a reminder, to submit a question, please send it through the question box in your webinar controls. Okay, so let me see here. Our first question is, does the equipment need to be turned off during the measurement?
Oh, the equipment that's being tested.
Correct.
I guess that depends on what it is. I don't know if Jeff wants to jump in on that.
Yeah, I can on Brian. There's really only one application, although it's a very, very important one, that is done on live equipment, and that's battery straps. The battery bank has to stay online. You can't shut that off, and it's got a charger up there that's putting a small charge current through the string, and that's running all the time. And so if you want to do battery strap testing, which is very, very important, because standby batteries, they can corrode really substantially, and then all of a sudden your electrical system goes down, the system being provided by the utility goes down because it was an accident on a pole or whatever, and you want your standby batteries to come on, and they don't, because they've been sitting there doing nothing for goodness knows how long, months and months, and the battery connections have corroded. So you want to periodically test all of those standby batteries to make sure that they will come online if the emergency ensues. And so in order to do that, then yeah, you can use a low resistance ohm meter and it'll perform the test in the presence of the charging voltages that are across the cells. But other than that, that's the only one that we really recommend, that it's okay to use a low resistance ohm meter test. Just about all your other testing, it is recommended, or in many cases, just not possible to do it on a live circuit. So you do want to have a de-energized circuit in all your other applications.
Okay. All right. Thanks, Jeff. The next question. Is the DLR02 protected from the inductive voltage impulse if the test leads are removed when the test current is flowing? An example would be if the test lead fell off a terminal of a transformer coil during coil resistance measurement. These voltages can sometimes reach several thousand volts.
Yeah, that's an excellent question. I'm going to defer to Jeff on that as well.
Yeah, I think that's something that doesn't normally come up. It's not a familiar question. I think we, Christina, if you'll keep that, the wordings and so forth on it. Yeah. We need to look into that. I can't give you an answer right off the top of my head, so to speak. But it's certainly an interesting question, and I would be glad to look into it for you. Yeah.
Okay. Sounds good. I will get you that info after. All right, then we'll go on to the next one. What are the specs and uncertainty of the DLR02? And what are available standards for a lab to perform an in-house CAL lab?
Good questions. Those are probably things we would need to answer by email.
Okay.
There are a number of specifications we get from, of course, the manufacturing site. And if they need to include uncertainties, typically a data sheet doesn't go into that much detail on that. I mean, I could read you the specifications right now, but that sounds like a lab setting. So we would want to provide more information than is available just off a data sheet.
Okay. Where do specs for acceptable resistance values come from?
Good question. In a lot of cases, and we take a lot of phone calls on this where folks are asking us, hey, what should this reading be? Typically would say that the manufacturer needs to provide that information. So what is a minimum or maximum resistance readings? And a lot of this is really just starting your own baseline as well. You want to have readings, as we mentioned, say during installation or commissioning of equipment, you want to set a baseline so that as you do future tests, you can look for that increase. So I think what the question there is, what are acceptable levels of resistance? And that's going to vary greatly from depending on the application and the equipment that's being tested. But just in general, we would refer you to the manufacturer.
One point on that is you can also always look at the standards agencies. So people like UL, IEEE, and NETA, and there's others, IECs and others.
Right.
Very often they will they will put out recommended standards for different types of equipment and different types of tests. UL, for instance, has a standard for everything electrical that you can possibly imagine. There's like one for table lamps and things of that sort. It's always good to look into those mainly because they give you an independent authority that reduces an awful lot of argument, discussion, and things like that. Because somebody could always say, well, you got that from the manufacturer. What do you expect them to say? But if you get it, a bit of a sarcastic response, but you do get that quite a bit. So if it comes from an independent standards agency, then that does reduce an awful lot of argument and litigation and things of that nature that can, take up your time for no real benefit.
That's a good point. Thanks, Jeff.
Okay, the next person says they have a power supply application. The volt is 1 volt, and they would like to measure the output resistance while operating. Can the DLRO2 do that?
Wants to test a power supply for?
It says power supply application, the volt is 1 volt, and he wants to measure the output resistance while operating.
I'm not familiar with that application. Jeff, do you have any comments on that?
Yeah, that's, we're always open to looking at something that may be a new application or something that's never been asked before. Certainly, it does violate the general caveat about testing on electrically dead, disconnected items. However, you're looking at a live item that doesn't have a whole lot of power behind it. And so you may be in a gray area that possibly it would work, but that would require us to take a closer look at it. And I'm hoping for the sake of the caller that the tester can maybe meet a 1 volt criterion, but it should be examined separately, and we'll be glad to do that.
Okay, for the next one, it says, hi, I work for a utility and we want to use a DRLO to test large diameter compression splices used on transmission and distribution conductors. Do you have any tips for connecting the DRLO to large diameter conductors, approximately 0.5 to 1.5 inches?
That's a really good question. I can tell you that there are a number of different test lead options that include Kelvin clips, probes, handheld probes, actually large clips as well. There are even clamps that can be used on circuit breaker contacts. I'm not sure if Jeff wants to add to that. That sounds like a question very specific, again, that we would probably manage a lot better via email. If we got a little more detail from the customer.
Well, I just wanted to add on that.
Added, typically a multi-strand conductor, if that helps with more information.
Okay.
Yeah, I think we can meet that. We'd have to actually look at the data sheet on it, but we have, for instance, screw down C clamps. that will accommodate the large test items. So I think we're okay, but we'll double check with the specifications that the caller sent in, and of course we'll provide the caller with a data sheet on the various leads options that we offer. But I think we're okay on that, and I think we can meet it.
Okay. All right, that looks like those are all the questions that have been submitted. So that concludes our time for today. If you have any further questions or would like to find out more about Transcat's product and service offerings, please contact us at 800-828-1470 or on the web at transcat.com. I want to also mention, again, everyone will receive a copy of the slides and presentation via email probably tomorrow. So we hope you got something out of today's presentation and that you continue to join us for Transcat e-learning webinars. Have a great day, everyone. And thank you to all the presenters. Great job.
Thanks, Christina. Thanks, everyone.
Thank you. Have a good one. Bye-bye.
Bye-bye.